All right, we're in Precalculus. We are on lesson 7-7, sequence word problems. Today's date is March 6. All right, so give me an example of an arithmetic sequence. We've been talking about this every single day.
2
2.
plus 4.
Oh, that's a series.
Oh, 2, 4, 6, 8.
2, 4, 6, 8. And what am I doing each time?
Multiplying it by 2. No, you're adding 2.
Adding 2. So adding 2, this 2 right here is called what? What is the name of that plus 2? It's called the common
Ratio.
Careful.
Rule.
It doesn't start with an R, but it does start for an R on this one. Common
What?
Common starts with a D.
Second letter.
Sign language. I.
Denominator.
Denominator is DE. But good guess. Difference.
Oh. What the heck? I feel stupid.
That's okay. Daisy, give me an example of a geometric sequence.
Is that when you're adding, like 2 plus 4?
So this was adding arithmetic.
Oh, arithmetic.
We just did a geometric sequence problem for the warm-up.
Oh, isn't it like 2, 4, 8, 12?
2, 4, 8.
Oh, 16.
16. And Daisy, what are you doing each time?
I'm multiplying by 2.
Multiplying by 2. Multiply by 2. And what is this 2 called? This 2 is called our common
Different.
Ratio.
Daisy has it correct. Rochelle, you had it correct last time if you applied it this time. Common ratio. So ratio is a key word there. Difference is the key word there. All right. So that was fun. All right. Now let's talk about the explicit formula. Let's get some review in here. What is the explicit formula for arithmetic sequence? So if I have, we'll do A for arithmetic. A of some term. This is going to be the term number. This is the, I'll do this in yellow. This is the term number. So I'm on the nth term. How do I find the nth term? A of n is equal to what?
The nth term.
I mean, yeah, it is the nth term. You're right. But what is the formula? I need the right-hand side.
A times the parentheses n minus 1 times minus 1 parentheses times right?
So I think you're doing recursive, right?
Oh.
I want the explicit. It's different from recursive. Recursive is an easy one. I don't really care about him as much. I'm not even going to review recursive formulas today, although it is going to be on the homework, because recursive is so easy.
A1 plus A2 over 2 times it by the...
You're really, really close. It does start with A1 because A1 is the, what does that mean? A1 is the, it's the first term, yes. So you always start with the first term. Just like with recursive, you start with the first term. And then what do I do after I get the first term? I multiply something times something. And it's going to be using this first, I'm going to use D or CD for common difference. I'm going to multiply the common difference. So I'm just going to say D, common difference. No, you're thinking about series right now, I think. We're doing sequences. I know, they're all over the place. We'll eventually get these all organized. But sequences, I take the common difference and I multiply it by, what's always the... Oh, you weren't looking when I did it. It's this n minus 1. Yeah, there's the formula. This is the common formula because they always will give you the first term. There is another formula that you can use, and it's not really helpful on today's homework, and it won't be helpful unless you go backwards in time on way back in time where we're talking about the 0th term to do 2 different formulas for explicit. But you could have done A of n is equal to A of 0 plus D times n minus 0. Exactly, Daisy. Yeah. So if this term and this term have to match, we'll just make that note. These two numbers right here and here, the 1 and the 1, have to match.
So what if it's like the third term? Would it be like A of 3 plus D of n minus 3?
Yep. Yeah, that works. Yeah. Daisy, give me another formula without 3, 0, 1. Those have been taken.
Wait, what?
So Rochelle told me a of 3 plus d times n minus 3. I told us a of 0 plus d times n minus 0. Give me another one.
So a of 5 plus d multiplied by n minus 5.
There it is, yep. Just make sure those numbers match and you're good. That's why you can have multiple formulas that are all the same formula, just rearranged differently. All right. The explicit formula for geometric. This is review from 2 days ago, from Monday. Hey, no hitting.
She said something bad about herself.
Don't say things bad about Rochelle. Rochelle.
Yeah, Rochelle.
All right. We'll say G for geometric. G of n. G of n is equal to what? It's very similar to arithmetic.
Was that what I said earlier? The a of 1 plus a of 2 over 2? No.
No. You're still thinking of series, I think. And it's still not quite correct for a series, but we'll talk about that later.
Okay, how about this? A of 1.
Yes. Well, we're talking about G now, right?
Oh, G of 1
G of 1, the first term.
times
Yes.
D.
Well,
Oh, no, R.
we'll
R.
call it R for ratio.
Sorry.
Yep.
Oops.
R.
You made me put R. I mean, D.
R of. I'm sorry, Daisy.
I have a pen.
Sorry.
I'm just kidding.
R of n minus 1.
R of n minus 1, like this, n minus 1?
Yes.
Yeah, careful.
Oh, that's raised to the power.
Raise to the power of n minus 1. Yeah, exactly. And make sure that these two numbers here and
What does
there
Oh, you should wait.
Those two numbers-
Yeah. When it comes to me, you should wait.
have to match. For example, if I use the 0th term and go backwards in time, if I go backwards in the formula or in the sequence to go to the 0th term instead of the first term, I could do g of 0 is equal to, or
I'm sorry.
I could say the 0th term is g of 0 times r to the n minus 0. Give me another formula.
G of n equals G of 100 times by r to the power of n minus 1.
Yes!
100 minus 1.
No, no, it's a n minus 100. You said it
Who's?
right the first time.
Oh,
Daisy, give me another formula.
Right there. Right there. I have to go in an address, like in the middle.
That's for
Oh.
Who are you looking for?
Gunner.
oh,
Gunner
yeah.
is right
Oh,
there.
he's right there.
Oh, dude, I'm literally going off the grid.
So.
We actually have name tags, unlike the sailor
1,000
joke.
Yeah, I know.
multiplied
That's very
r to the power of n minus 1,000.
Yeah, man, we're good at this. You guys know what you're doing. You girls know what you're doing.
McDonald's fries taste like Pringles.
What? How does that relate to anything that we just said? And that's so random, and I don't even know if it's true. I don't know if McDonald's fries, I don't think taste like Pringles. I mean, they're both salty and they're both potatoes, so.
You should bring McDonald's and Pringles for 4th period, and we should test them out.
Okay. Go get me McDonald's fries. We'll make a taste test. All right. Recursive formula. A of 1 is equal to some term.
Yeah. Okay.
Is equal to something. And just put the first term here.
Yeah. Okay. But I think you're fine.
Sorry.
A of 1 is equal to the first term.
What?
What?
All right. Here is the key. The main thing that you need to take away from recursive formulas for arithmetic and geometric sequences. Do I do a plus or times?
Ooh, times. I'm just kidding.
It's going to be add or subtract, exactly. So I'm going to do plus or minus. You get to choose one or the other. It's not both.
Well, technically it's add, but if it's gonna be a negative number, then yeah, you gotta add.
So adding a negative or is the same thing as subtracting. So you can make that argument. Add or subtract, and then what are you going to call this thing? We'll call it the D again. We'll call it the common difference. D, which is the common difference. Like that.
Wait, how do you do your D's? Just to write them down.
I'm trying to do it all in one, I guess.
That's how I do it.
I go like that, but
Oh.
I don't want to do it in two parts because when I'm writing digitally, I should be doing it all like that.
That's how I do it.
I should be doing them like that.
I'm
like
gonna
that.
take an A with the long.
This is technically a lowercase delta. If you look up there, there should be a lowercase delta. It's all one swoop.
I am blind.
Where's
Oh,
Delta is
wait.
like
Don't look at it. Wait.
You know what?
Wait.
Delta looks like the lowercase Delta looks like from Mario with that flying thing.
Oh my
The one where
god.
it's like a
What are you
Wait, I don't know where it is. Which one is it?
yeah.
Oh, that one.
I mean,
It-
it should have a little swoop on it, I guess. But it is basically a lowercase d.
The Greek.
Here's, for those of you watching the video, it's this lowercase delta with a little swoop on the top of it.
Well, technically, it looks like a T on top of its head.
Anyway, again, you have g of 1 is equal to the first term. Don't know what that is, but there it is. There's the first term. And then here's, again, the key. The most important thing is it's going to be what? Here. What symbol? What operator?
R.
Well, I mean, it is going to be multiplied by a ratio.
I'm sorry,
Yep. And that's going to be the common ratio.
Multiplication or just multiplication.
Multiplication. Only multiplication. Multiply. And that's the key part. Cool. Let's do 2 examples and be done with the notes. All right, so have you guys heard the story about the chessboard where wheat or rice, whatever story you're talking about, is placed upon the first square? So one, what is it? Is it kernel of wheat? What do you say of wheat? What units of wheat are we in? Let's say, oh, grain. It just has it right there. 1 grain is on the first square, 2 grains on the second, 4 grains on the third, 8 grains on the fourth. Do you know how many checkers there are on a checkerboard for chess?
I don't even play chess, so
It's 8 by 8.
I'm a little bit
So it's
confused.
16. No, 61.
64.
64, yeah.
Oh.
There are 64 squares, yeah. All right, so we're going to let Fn be the sequence of grain on the nth square. All right, so technically we could do a series if we added up all the rice on each square, but I'm just looking at individual squares right now, so it's a sequence. Which sequence is it? Is it arithmetic or geometric?
Geometric.
Arithmetic.
I don't know.
All right, so the question is, are you multiplying or are you adding?
Oh, you're adding.
So notice that this one has adding, this one has multiplying. Multiplying is geometric, adding is arithmetic. So if I come down here, what am I doing each time to get from 1 to 2 to 4?
You're adding
Add 2.
Oh, wait, no. You're
Oh, wait.
multiplying by 2, yeah.
Multiplying by 2. So multiplying means,
Well, but technically right now we don't know
Geometric.
yet because it only gives us 2.
no, it
If
gives
it
us
gi- if it
1,
gi-
then 2, then 4.
Yeah, but it could be like adding 2. Or it could be multiplying to 2.
No, it goes from 1 to 2. How do I go from 1 to 2?
But then also you can multiply 2 to 1 and it gets 2.
No, it's
So multiplying is the only way that you can do this, but what you're saying does talk about this really cool mathematical theorem. I don't know exactly what the theorem's name is, but it basically says even if you have 1,000, if I told you 1,000 numbers, you couldn't be sure that you knew the
Wait.
1,000th and first number.
Wait, it's 1, 2, and 4.
Yep, that's why I underlined those.
that's what the
So
yes.
yeah, but so that means that you're adding. So that means you're multiplying. Okay.
Yep.
But listen, wait, don't.
So it
don't
comes full circle, so it is B because you are multiplying by 2. Yes. So generally think, or when we write this down in our notes, we want to say arithmetic, that's when we add. Geometric is when we multiply. I mean, technically arithmetic, you can add or subtract. We'll just do the plus to simplify our notes. Yeah, but I do want to bring up this theorem. So this is a total tangent. You don't have to write any of this down. Don't write any of this down. I'm going to come down here to my summary on the back. But let's say I have the numbers 1, 2, 3, 4. I bet you can't tell me what this number is.
5.
It's not 5.
What?
So it's this really fun theorem of mathematics where you never have enough numbers to actually complete the pattern. Because here's what the next number actually was, 10.
Why?
Boom, because now the pattern is 10, 20, 30, 40,
That doesn't
100.
make sense.
200, 300.
So when it goes to 400, it's
400.
going to be 1,000.
Oh, no, now this is all one sequence. See, the whole point is you never know the sequence unless I actually tell you the rule. But we do know the rule because I tell you it's arithmetic or geometric. I know, it is frustrating. I can just all of a sudden be like, oh, now we're going to switch to ratios. Now I'm going to do 1 over 3, 2 over 3, 3 over 3, 4 over 3, 100 over 3, 2 or 10 over 3, 20 over 3, 30 over 3, everything here divided by 3, and then you still don't know what the next value is.
Don't yell at me.
You still don't know. The whole point is you never have enough values in your sequence to know what the pattern is. Truly know. I mean, you can make an educated guess, but you
So-
never, ever know.
So really, what if you're really what if you're... Never mind.
All right, so I'm telling you that you have only two options. You're either adding or multiplying, which does narrow it down so you do actually know the sequence.
What if you're multiplying it by 4 over 2?
That's 2. All right, so now the hard part. Write an explicit formula for the sequence of this chessboard problem. Help me out. Explicit formula. It's going to be geometric. We know that already.
It's going to be g of n.
Well, okay, so we're going to, it doesn't need to be g of n.
F of n.
It can be, yes, it can be anything. F of n, a of n, theta of n. F of n is equal to,
F of n minus 1 times by 2.
well, that's the general formula. And now I need to actually use the formula. What is g of 1?
Oh.
1.
Yeah.
G of 1 is 1. Yep, so 1, come back here. 1 times, now I need to come back up here and say, I'm timesing it by the common ratio to the power of n minus 1. So this common ratio to the power of, what is common ratio?
2.
2 to the power of,
0.
no, just leave it as n minus 1. N minus 1. Cool. I can give you another formula. Are you guys ready for it?
No.
F of n is equal to 2 times 2 to the power of n minus 2. I can give you another formula. Ready? F of, I'll do it in a different color.
Is it? Oh, I see. So f of n equals to 4 times by 2 of n power of n minus 3.
Yep, that's another formula. There are so many formulas that you can do for this one. You want to try a harder one? This one actually doesn't work. Actually, I don't want to talk about it because it's, I've already got enough tangent. Just do it! Do it! Alright, so f of n. Is it possible for me to go backwards to, could I go to 0? No, because I'm really, if I'm multiplying by 2, going backwards, I'm dividing by 2. 1 divided by 2, is that 0? 1 divided by 2 is just 1/2. 1/2 times 2 to the power of what?
n minus 0.
N minus 0, which is just n. Yeah, so that's another formula. There's our fourth formula. All right, let's go to example 2. On the back, flip papers. Example for what literally happened yesterday.
Arrow.
This may be making paper cranes for India. Yeah.
15.
I had a guess. I guesstimate that she makes 15. How many does she have on the desk behind you right now?
17 or 18.
14, 15, 16, 17, 18, 19, 20, 21, 22,
Okay.
24, 25, 26, 27.
Okay, so we were off by a lot when we said 15. We should have said
Wait,
27.
I say 11.
Do you guys want to change it to 27? By the way, Sophia stole one of them. I'm recording this too. Sophia stole one of India's paper cranes that Arrow made for her.
29. It was 29 with the one that Sophia stole.
All right, so let's change this to 29. Let's make it a very accurate
Well,
problem.
actually, yeah, 29, but I must do 1 too.
29. All right, so every day Arrow makes 29 paper cranes. Today made with blue sticky notes. All right, so what type of sequence is this?
Oh, wait. Adding, right?
So
She's adding to.
adding each day, yeah. So therefore, is it arithmetic or geometric? It is indeed arithmetic because arithmetic is adding, geometric is multiplying. All right, now the next part. I mean, obviously, if I asked you instead of an explicit formula to do a recursive formula, it's pretty easy. Just do the first term, do the common ratio or common difference for this one. But explicit formula, how am I going to do it? Now that it is an arithmetic.
Let's do P of n because of paper.
Okay, P of n is equal to what?
29. No. Yeah.
So assume that you didn't start with any paper cranes.
Also 0.
0. Yep. 0 plus
29 to the power of. I mean, times by parentheses of n minus 0. 1.
n minus 1, yeah. Because on the first day you assume that you didn't have any paper cranes. I guess I should have made that more explicit in what was happening. But before, India didn't have any paper cranes, and now she has some. Or maybe I could have changed the problem, like maybe India's mom gave her 2 paper cranes, so she has an initial value of 2. But yeah, there we go. Give me another formula. What's another one that works? P of n could also be what? Let's see if it's in a different color.
It can be 2. What's 29 plus?
29 plus 29 is 58.
So we could do 58.
or 29.
To the power, I mean, to the power, to times by n minus 2.
Ooh, careful though. That's actually not going to be right.
Oh, 3?
Yeah, n minus 3 will work.
Oh, because on the second she has 29.
Mm-hmm. Yeah, Daisy, you want to do another value, another formula for p of n?
No, I'm over there.
Go for it. Change this to like n minus 2 or something. N minus 2. How many does she have after the first day? She has 0. How many does she have after the first day on the second day?
29.
There it is. 29 plus 29 times n minus 2. There's 3 different formulas you could use. All of them work. Does that mean if we went backwards in time, Mr. Sindel, where we had p of -1, that India would have -29 cranes? No, that doesn't make sense in the context of the problem. That's outside of our domain. Our domain was n is 0 or bigger. All right, that's all I have for the notes. Any questions? All right, go ahead and write your summaries.